There's a bone sitting in a lab in Johannesburg. Small, brown, unremarkable at a glance. It belonged to a hominin who lived 1.7 million years ago. We don't know their name. We don't know what they looked like. We barely know which species they were. But we know one thing: they had cancer. Not a metaphor, not a theory. An actual tumor, preserved in bone, from a creature who lived before our species existed. Before agriculture, before processed food, before cigarettes, before everything we've been told causes cancer. That discovery made a lot of people uncomfortable, because it wasn't supposed to be there. For decades, the dominant story was simple. Cancer is a disease of modernity. We invented it, with our bad diets and our pollution and our sedentary lives. Ancient humans were healthy. They died young, sure, from predators and infections and cold, but not from tumors. Go back far enough in human history, and cancer basically vanishes. That story is wrong. And the way it unraveled, through bones and mummies and ancient DNA, through labs that didn't even exist 20 years ago, tells us something nobody really wants to hear. Cancer was always here. It just hid. Let's start with why anyone believed the modern story in the first place. The logic wasn't stupid. When doctors in the early 20th century started cataloging disease across populations, cancer rates appeared lower in rural, less industrialized regions. The further back you looked, ancient Egypt, medieval Europe, prehistoric burial sites, the less cancer you seemed to find. In 2010, two researchers at the University of Manchester, Rosalie David and Michael Zimmerman, published a paper in Nature Reviews Cancer, making exactly this argument. They combed through Egyptian mummies, South American remains, ancient literary records, thousands of years of skeletal evidence. What they found, or rather what they didn't find, was their entire thesis. Across hundreds of mummified remains, they identified only 5 confirmed cases of malignant tumors. 5. Zimmerman's conclusion was stark. In an ancient society without surgery, evidence of cancer would be preserved in virtually every case. So if you're not finding it, it probably wasn't there. Cancer, they argued, is caused by factors that only arrived with industrialization. Clean thesis, made intuitive sense, got a lot of press. It also had a serious problem. The problem was how they were looking. Here's something most people don't know about cancer in the archaeological record. The majority of cancers, the ones that begin in the lungs, the liver, the breast, the colon, leave no mark on bone. Soft tissue rots. It doesn't fossilize. So when you're searching for ancient cancer, you're already searching through a keyhole. The cancers that do leave skeletal traces are the ones that either start in bone or metastasize there. And even those are easy to miss. For most of the 20th century, paleopathologists diagnosed ancient bone cancer the same way they diagnose a broken leg, by eye. You look at the surface of the bone. If there's a visible lesion, you flag it. If not, you move on. But that's not how modern oncologists find cancer in living patients. They use CT scans. They use X-rays that penetrate the interior of the bone. Because cancer that spreads to bone often does so from the inside out. The exterior can look completely normal. In 2021, a team at Cambridge decided to apply modern diagnostic tools to ancient remains. They took 143 adult skeletons from 6 medieval cemeteries, bones that had already been examined and cleared by visual inspection, and ran them through CT scanners. Previous assessments had suggested cancer was present in around 1% of these individuals. The scanners found cancer in an estimated 9% to 14%, nearly 10 times more. The ancient cancer rate wasn't low because ancient people were healthier. It was low because no one was looking properly. So what does the evidence actually show when you look hard enough? Go back 1.7 million years. Swartkrans Cave, South Africa. A limestone formation near Johannesburg that researchers call the cradle of humankind. A foot bone from a hominin, possibly Paranthropus robustus or early Homo, shows clear signs of osteosarcoma, bone cancer. The same aggressive malignant disease that still strikes mostly children and young adults today.
In the same research, a separate find pushed the record even further. A 1.98 million-year-old vertebra from a young Australopithecus sediba showed evidence of a tumor growing on the spine. Almost 2 million years ago, a child, barely past the point of being ape, had a growth on his backbone. Then, jump forward, 120,000 years ago, Krapina, Croatia. A rib from a Neanderthal shows clear evidence of fibrous dysplasia, bone cancer. The researchers don't know the individual's sex or exact age. They don't know if this cancer killed them, but the evidence is unambiguous. These weren't isolated accidents. A systematic review of 154 paleopathological studies documented 272 archaeologically recovered individuals with confirmed skeletal or soft tissue evidence of cancer, spanning from 1.8 million years ago to 1900. And those are just the ones preserved well enough, found by people looking hard enough, with tools sensitive enough to catch it. The real number is unknowable, but it was never zero. Here's where it gets stranger. Cancer didn't start with humans. It didn't even start with mammals. The earliest confirmed benign tumor in the fossil record comes from a fish that lived 300 million years ago. Later cases appear in Jurassic dinosaurs, Cretaceous hadrosaurs, European mammoths. The earliest true cancer, a malignant tumor, comes from a theropod dinosaur in the late Jurassic of Utah, 300 million years. Cancer predates every creature we'd recognize as familiar. It predates the continents as we know them. Why? Because cancer isn't a foreign invader. It's not a virus or a bacteria or a parasite. It's the body's own cells misfiring. Every time a cell divides, there's a chance of a copying error. The more cells divide, the more chances for error. That has been true since the first multicellular organism, and it will always be true. As oncologist Siddhartha Mukherjee wrote in The Emperor of All Maladies, civilization didn't cause cancer. By extending human lifespans, civilization revealed it. That distinction matters more than it might seem. Cancer is fundamentally a disease of accumulated damage. The longer you live, the more cell divisions happen. The more cell divisions, the higher the probability that something goes wrong and the immune system doesn't catch it in time. Most cancers become clinically significant in people over 60. In ancient populations, most people didn't reach 60. Not because ancient life was uniformly brutal. That's an oversimplification. But because infant mortality was devastating, infections were untreatable, and injuries that are now routine could be fatal. The people who survived all of that and reached their 40s were already the most physically resilient individuals in their group. And yet cancer still found them. Because the natural causes of cancer, UV radiation from the sun, oncogenic viruses, radioactive radon gas from soil and rock, have existed since the beginning of life on Earth. Ancient humans spent their entire lives outdoors. No sunscreen. Direct UV exposure from birth. And certain parasites and bacterial infections, extremely common in pre-modern populations, are now recognized carcinogens. Helicobacter pylori, which causes stomach cancer, was nearly universal in ancient gut microbiomes. Schistosoma, a parasitic worm common in ancient Egypt, causes bladder cancer. These weren't modern inventions. So the cleaner picture isn't ancient humans didn't get cancer. It's ancient humans got cancer, often at meaningful rates, but they usually died of something else first. And we couldn't see it in the bones because we weren't looking right. Egypt is worth staying in for a moment, because what the ancient texts say is almost as interesting as what the bones show. The Edwin Smith Papyrus, dated to around 1600 BC, but believed to copy material from as far back as 2500 BC, describes cases of breast tumors, hard, spreading masses. The text documents them with clinical precision, describing the texture, the growth pattern, the prognosis. And for treatment, in one of the oldest medical documents in existence, it gives an answer that is honest and bleak. There is none. Egyptian physicians, 3,500 years ago, were looking at cancer, recognizing it as something specific and serious, and concluding there was nothing they could do. That is not a society discovering a new disease. That is a society that has seen it enough times to develop a protocol for it. Later texts describe surgical removal of surface tumors, cauterization, pastes applied to growths. None of it worked reliably, but the attempt tells you something. Cancer wasn't a curiosity to Egyptian medicine. It was a recurring problem worth developing responses to. Then ancient DNA arrived. Cancer is, at its core, a genetic disease. Cells mutate. The breaks that stop runaway division break down. The cell replicates out of control. Those mutations leave specific signatures in DNA, patterns that oncologists can identify in living patients today. When researchers started looking for those signatures in ancient remains, they found them. Not just in Egyptian mummies, in medieval skeletons, the Bronze Age remains, in Neolithic teeth pulled from burial sites across Europe. A 2019 study examining skeletal remains from a medieval English cemetery found genomic signatures consistent with lymphoma in multiple individuals. Another analysis of Bronze Age remains from Central Europe identified mutation patterns associated with colorectal cancer. These weren't clinical diagnoses. Ancient DNA work produces probabilities, not certainties. You're working with fragments, filling gaps, making inferences. But the patterns were consistent across independent samples from completely different populations and time periods. Cancer was not waiting for modernity to invite it in. It was already there, in the cells of people who died thousands of years before the Industrial Revolution, leaving the same molecular signature it leaves in patients today. And in 2016, researchers studying ancient DNA began finding something else. Certain gene variants that increase cancer susceptibility, variants we now screen for in living patients, appear in ancient human genomes. Not universally, but they're there. The susceptibility was always coded into DNA that predates agriculture, predates writing, predates fire as a controlled tool. None of this is an argument that lifestyle doesn't matter. It does. Smoking causes lung cancer. That's established. The decline in smoking in Western countries since the 1960s produced a measurable, documented decline in lung cancer rates. HPV vaccination reduces cervical cancer. Obesity is linked to at least 13 cancer types. Diet, chronic inflammation, alcohol, all of these influence risk in ways that are real and that people can act on. The 2021 Cambridge study estimated cancer prevalence in medieval Britain at 9% to 14% of adults at time of death, compared to 40% to 50% in modern Britain. That's a real difference. Modern carcinogens have genuinely increased risk beyond what aging alone explains. Tobacco is real. Industrial pollution is real. But that is a different argument from cancer being man-made. The Manchester paper got the conclusion wrong because it read absence of evidence as evidence of absence. It looked through a keyhole, found little, and assumed the room was empty. The room was not empty. Back to that bone in Johannesburg. A hominin, 1.7 million years ago. Osteosarcoma eating through their left foot. Probably painful, probably fatal. Probably terrifying in a way there were no words for yet. We don't know what they experienced, or if anyone around them understood what was happening. We know they lived with it long enough for the bone to show the lesion. Long enough for it to be preserved through 1.5 million years of geological time. Long enough to end up in a lab where a paleoanthropologist put it under a scanner
and recognized something familiar. The oldest known cancer in a human ancestor, looking exactly like the tumors in hospitals today. Cancer is not a punishment for how we live. It is not a failure of civilization. It is an old problem, the oldest. And for most of human history, we died of other things before it could finish the job. We just got better at surviving long enough to see it clearly.